Welcome back to part 7 on quadratic functions and modeling. We can define local min and local max for any function in a specific window. Find the local maximum and minimum of the following graph. Well, you might not know what a local max and min mean, but basically all you're looking for is a comparatively low place. So if you think of where water would drain to if you were to sprinkle water from the top down, where would that go? So it would roll down the high points and it would land in the low points. So we have a low point at, let's see, -6, -5. We have a relatively high point at -3, 4. We have a low point at 2, -7, so 2, -7. And we have a relatively high point at 5, 7. And I just think it's important to recognize that this is an odd degree polynomial. We haven't talked a ton about this yet. But notice that to the left, the polynomial approaches positive infinity, and to the right, the polynomial approaches negative infinity. As x approaches positive infinity, the function goes downwards. As x approaches negative infinity, the function goes upwards, which means there is no universal maximum or minimum in this situation. When you have an even polynomial, then you will either have a maximum or a minimum. And it will be a universal one because there can be no other point that is lower or higher. This might be good to just keep in mind because if it's an even degree polynomial, that means that you could possibly have a universal max or min. In fact, you will. The local maximums occur at -3, 4, and at 5, 7. The local minimums occur at -6, -5, and at 2, -7. It's not always obvious where these points are when you're graphing functions on your calculator. It's also not obvious when you have an incredibly tall polynomial and you can't clearly identify where those maximums and minimums actually lie. And so we're going to use a calculator to find these maxes and mins. Let's start with example 7, where it says graph h of x equals x to the 5th plus 5x squared minus 4x minus 3 in the standard window. The standard window is when you click on zoom on your calculator, and then from zoom you click on 6, which is also known as aka Z standard. And this will set your calculator window back to default when you graph. So let's do that first. We'll turn it on. We will go to window. And I think this is already set up to be in Z standard, but just in case you don't know how to do this, click on zoom. And then Z standard is number 6. So you can either push 6, enter, or arrow down to Z standard and hit enter. And there is your window. We are asked to graph this function here, this x to the 5th, etc. It is an odd degree polynomial, so we will not have universal maxes or mins, but we will have local maxes and mins. Click y equals. Then enter your polynomial. Then click Graph. And you can see that this function goes through the x-axis 3 different times. If you wanted, you could spread this out just a little bit, because right now we're seeing negative 10x to positive 10x. We could actually shrink that down and just look at negative 5x to positive 5x, and we'd still have a nice window. So let's just change it for fun. We'll make our x-min be negative 5 and our x-max be 5. And I just want to show you what that does. It stretches out the interesting part of the graph. It's just a little easier to see. Standard form is usually what you want to start with. I want to find the local maximum and the local minimum. I will do this by clicking second, calc, maximum, which is number 4 on my calculator. I need to arrow to the left of the maximum point. So think of this as your horizontal axis, so you're shifting to the left, and the little spider is crawling along the graph respective to where you are on x. So I need to be to the left because it's asking for the left bound. I'm clearly to the left of the high point, so I'll hit enter. Now I need to arrow to the right side of the high point, hit enter, and these arrows have now appeared to bound my maximum. Now I'm supposed to guess, so I put the little spider cursor thing right at the maximum point, and I hit enter a third time. And it gives me the coordinate in x and y for that maximum. There is a local maximum at negative 1.4, rounding to 1 decimal place, comma 7.0. So this is my local max. Now let's find the local min. This will be the low point. So second, calc, minimum, which is 3. I need to go to the left of the low point. Well, here's the low point right about here. So I need my cursor to be to the left of the low point. Hit enter. Now go to the right of the low point. Hit enter again, and then guess where the low point is, and hit enter a third time. My local minimum is claiming to be at 0.4, negative 3.8. Again, rounding to 1 decimal point. We need to also sketch this. Notice that it crosses the y-axis below the x-axis, and that looks about right. You could label this point here as the local max, and you could label this low point here as the local min. Let's adjust the window now to -2, -1, 3, 8. If you haven't seen this notation before, this means the x min, the x max, the y min, and the y max. We're going to go from -2, and make sure you're not putting a -2 in. The minus sign here is not the same as a negative, unfortunately. So you have to use the -2. The x max is -1. Leave the scale at 1. The y min is 3. And the y max is 8. Let's graph it again. We'll calculate the maximum. We'll go left bound is good, right bound. It takes longer to get from one side to the other because it's zoomed in so much. And then guess. And sure enough, it's the same values as before, -1.4, 7.0. If all you see is this little piece of the graph, then it's not going to appear that you have a giant polynomial with a maximum and a minimum. So if you see this type of a function graphed in your calculator, you need to probably zoom out, change your window, go back to Z standard, maybe zoom out even further. You know, you learn how to do this with trial and error, so it's not something that I can just magically impart to you. You're going to have to work on this so that you can see how your calculator responds to changing the window size. So that's kind of a general shape of the maximum, the local maximum at -1.4, 7.0. Now we're going to adjust the screen to a different area. Let's change our window. So now it goes from -1 to 2 and from -5 to -1. Let's graph that. And notice we are only seeing the low point now, the local minimum. So sketching this, we are just seeing kind of this portion of the graph. And again, we've already found that point, but let's just try it one more time. Second, calc, minimum. Find the left side of the minimum, hit enter. Find the right side of the minimum, hit enter again. Find the low point as best you can, that's the guess. Hit enter a third time. And your minimum is at 0.4, -3.8. I would pause the video here and give it a try, see if you can recreate this on your own. It may look a little bit easy when you see somebody else using their calculator, but it can be a little quirky and every calculator is slightly different, so make sure you recreate this on your own.